because it's not really a focus of a problem. Okay, so first one I want to take a look at. Okay, so there are two kinds of problems on the exam involving change of variables. One type is where I give you the transformation to use. Although you need to figure out, you need to know what kind of region you're mapping to and from. So for instance, this problem right here, this is 12.8, number 14. So we have a double integral, x squared minus xy plus y squared. And R is bounded by an ellipse. And the ellipse is just this expression, plus u, is equal to 2. And the change of variable you're supposed to use is x is square root of 2u minus square root of 2/3 v. Y is square root of 2u plus square root of 2/3 v. Okay. All right. Now, first thing to focus on is, so we're going to have a new integral over a different region, r tilde, which we don't know what it is yet, but we'll find out. And you're going to replace x and y with these expressions in terms of u and v. So you're going to have square root of 2u minus square root of 2/3 v squared minus x times y plus y squared. Okay. And then you have a Jacobian that we need to include, dxy duv, which we're going to figure out in a second, times, or with respect to, u and v. Okay, so this is going to be our new integral, but we don't have all the information yet. We need to know what r tilde is, and we need to know what this is. Now this is the easier thing to figure out. Let's get that out of the way. So we need duv is the determinant of a Jacobian. So it's dx du, dy dv. I need the absolute value here. Minus dx dv, dy du. In this case, the partial derivatives are pretty straightforward to compute. So what are the partial derivatives that we need to fill in here? What's partial of x with respect to u? Yeah, square root of 2. And partial of y with respect to v? Square root of 2/3. All right. A minus partial of x with respect to v? Yeah, minus square root of 2/3. dy dv, which is square root of 2 again. So what we're going to get is, here we get square root of 4/3 plus that again. So it's 2 square root of 4/3, or we get 4 over the square root of 3. So in this case, we get something nice. It's just a constant, because x and y depend linearly on u and v. And that's what's going to happen in a lot of cases, that the changes of variables might not be all that complicated necessarily. Okay, so that's one thing we need to know. The other thing we need to know is, what is it that we're going to be integrating over? Well, here we have an equation in x and y that defines the old region. So if we replace this with an equation of u and v, we can figure out what the new region is. Of course, as we can see from this, it's going to get ugly. So
How'd you get 4 with the square root of 3?
Oh, I hope I didn't mess up here. Okay, so I have square root of 4 over 3
Right.
from this term,
Okay.
plus the same thing. So I get 2 square root of 4 over 3.
Okay.
Yeah, and then I took the square root.
Right. That should be 8 over the square root of 3.
That's where it goes.
Okay, all right.
Okay,
I'm working on it.
okay,
Just go on and I'll work with it.
okay.
Algebra, I gotta fight back.
All right. Okay, so what we have here, if we multiply this out, we're going to get 2u squared minus 2 square root of 4/3 uv plus 2/3 v squared. This is x squared. Y squared is going to be the same thing except with a plus in the middle. And then u times v, or x times y rather, is going to be, we have a difference going on here, so we're going to have 2u squared, it's going to be minus, so we're going to have minus 2u squared minus 2v squared. Okay. So now what we're going to do is we need to add all of these up. So we're going to have these cross terms involving u and v, they're going to cancel out. And then here we have 4u squared minus 2u squared. So we're going to add up all of these. So x squared minus xy plus y squared is 2u squared. And then we have 2/3 v squared. Again, so we have 4/3 v squared. And I have 2/3 there as well. So we have 2/3, 2/3, and plus 2/3 again. So I get 2v squared. And all of this is equal to 2.
Yeah, point out the sign to him.
He's on the other side of the hall.
Oh.
So all of this is equal to 2. So when we write this in terms of u and v, I don't care. So all of this is equal to 2, so that's why I've equated this to 2 here. So what do we have? We've mapped from the ellipse x squared minus xy plus y squared is equal to 2 to the circle u squared plus v squared is equal to 1. So now we know exactly how to integrate over this. So let's write out what the actual integral is now.
Oh yes, on the DVDs, I bet her voice wouldn't be audible either, because it's a directional microphone.
Oh, okay. So our total is a unit circle, and we have 2u squared plus 2v squared. Then we have our Jacobian, 4 over the square root of 3 du dv. So, and since this is just a circle, we can convert this to polar coordinates, relating uv to r theta.